Hi, good afternoon, you guys. Today we're going to be doing the Unit 5 study guide for everyday math. So let's get started. Number 1 is asking you to write an equation to show 4/5 as a sum of the unit of fractions. So think way back to the beginning of this entire unit when we needed to figure out how to decompose our fractions, make them smaller so that when we add them up together we get that total sum there. So one example, and you can have a couple different examples, might be 2/5 plus 2/5 equals 4/5. There are lots of options. Like I said, another one could maybe be 3/5 plus 1/5 equals 4/5. Moving on to part B of this one, it says decompose each fraction in two different ways. I want you to make sure that you focus on this two different ways direction. So you're going to be doing each fraction two different ways. Write the equations to show each fraction as a sum of fractions with the same denominator. This is one area that I've had students lose points on the test because they only show me one way instead of two ways. So let's do 11/12. There are lots of options again, like I said. I'm just going to quickly come up with a couple. Let's say 10/12 plus 1/12 equals 11/12. Another option, because remember we have to show two different ways, might be 5/12 plus 5/12 plus 1/12 equals 11/12. Going down to 1 5/8, this is a mixed number. So one of the best ways to do this is to take your 1 whole here and look at the denominator within the mixed number and say, oh, since this is eighths, I could turn this 1 whole into 8/8. So you might say 8/8 plus 5/8 equals 1 5/8. A second option, because remember you have to show it in two different ways, might be to flip-flop your mixed number into an improper fraction first and find out what some fractions you could add up would be that way. So remember, thinking about the process of changing a mixed number to an improper fraction. You're going to go times plus. 8 times 1 is 8 plus 5 is 13. So if we know that this fraction would become 13/8, we might say something like 7/8 plus 6/8 equals 13/8, which is the same thing or equivalent to 1 5/8. Moving on to number 2, you're expected to use a geometry template, and I don't have one with me right now, but you're welcome to use one. And you're going to draw the solution. Notice you're expected to draw it. This is worth 1 point on your assessment. Then you're going to write an equation to show your answer as well, so this math problem would be worth 2 points. When we talked about these in class, I stressed to you not to look at the picture or the graphic, rather focus on the fraction that they're giving you to represent that picture. So this picture right here, they're saying is the same thing as 1/2 of the whole. So if we were going to draw this using a geometry template, and mine's not going to be beautiful, but it'll be close enough. Here's our 1/2, and then I'm going to connect to that a second one to represent the other half. This is my picture because I have to draw the solution for 1 point, and then I'm going to come down with my equation, and I'm going to say 1/2 plus 1/2 equals 1 whole. Moving on to number 3. It says to use manipulatives or drawings to help you solve the problem. This is just an if you need to help you. We've talked about adding fractions in class, and maybe not just 2 fractions, but more than 2. Here's a number story that says, Tam, Marta, and Tachina each shared a container of cottage cheese. We stop at the end of the period to make sure we understand. These 3 ladies are sharing a container of cottage cheese together. Then they tell us, Tam ate 3/10, Marta ate 2/10, and Tachina ate 4/10. So how much cottage cheese did they eat? That should tell us that we are going to be adding these fractions because we need to find out how much they ate altogether. We need to give a number model with an unknown. This is going to look like 3/10 plus 2/10 plus 4/10 equals maybe C for the container of cottage cheese. When we add these numerators together, we say 3 plus 2 is 5, 5 plus 4 is 9, and we'll come down here on the answer line and we will say 9/10 container of cottage cheese. Over to question 4, we have another number story. This time, though, we are looking at mixed numbers. It says Julia used 2 2/3 cups of green beans to make a casserole. Stop at the end of your period and make sure you understand what you just read. Julia just used 2 2/3 cups of green beans. Isaac used 3 2/3 cups. Okay, how much green beans, that should say how many green beans, did they use together? When we see this word together, once again, that's going to let us know we should be adding. We need to give a number model with an unknown, so we're going to say 2 2/3 plus 3 2/3 equals. We have the simple strategy of adding our whole numbers first. 2 plus 3 equals 5, and then adding our fractions. 2/3 plus 2/3. 2/3 plus 2/3 equals 4/3. And you might be thinking to yourself, oh no, that's an improper fraction. That's all right. Let's find the equivalent. We ask ourselves how many 3's can go into 4 without going over. We know that 1 3 can fit into 4. That's 1 whole 3. And then we've got 1 left for our numerator after that. So 1 1/3 is an equivalent mixed number to 4/3 improper fraction. We're then going to add up our whole number from above and our mixed number from below. 5 plus 1 1/3. And I'm sorry, I should be giving you a C for casserole up here as an unknown, is 6 1/3 cups of green beans. It's a lot of green beans. Going on to number 5, this tells you to use manipulatives or drawings to help you solve the problems if you need to, but once again, you do not have to. This is simple addition of fractions and mixed numbers. Letter A should be pretty easy. We see our denominators are the same, so we just need to add our numerators. 2 plus 4 is 6, 6/7. Same thing over here. 3 plus 3 is 6, 6/4. And once again, we see an improper fraction, and so we're going to simply flip that to a mixed number. How many 4's can go into 6 without going over? It's going to be 1 whole 4. We have 2 left over for our numerator, and 4 is our denominator. This is a better answer than this, although they're both correct. There's an even better answer, and that would be to reduce this 2/4. We know 2/4 is equivalent to 1/2, so we could actually say 1 2/4 is equivalent to 1 1/2. Any of these 3 answers would be considered correct. This is a good one. This is a better one. This is the best. Down on letter C, we're going to be adding mixed numbers again, just like we did earlier. 1 plus 3 is 4. Oops. And 4 plus 3 is 7. Our denominator stays the same, so we're finished with this mixed number. When we come over to letter D, however, we're going to notice that we end up with an improper fraction again. 4 plus 2 is 6. 3 plus 4 is 7 for our numerator, but our denominator is only 5. So this is an improper fraction right now. It's all right. All we're going to have to do is ask ourselves how many 5's can go into 7. We know that 1 5 can fit into 7. We have 2 left to get up to 7. So it's 1 2/5. We're going to add our 6 plus our 1 2/5, which is going to equal 7 2/5. Once again, this 6 7/5 would be an okay answer because it is equivalent to 7 2/5, but 7 2/5 is the better answer.